This mini split inverter air conditioner, which didn't work after installation, has now been uninstalled. It has a manufacturing mistake in the outdoor control board. This is a brand new air conditioner from Sharp Company of 1.5 tons. The indoor unit is in working condition, but the outdoor is not working at all. Its outdoor control board has two switching relays. This is a soft start relay used for turning on the SMPS and continuously supplying power to it. This power relay gives an electric supply to the IPM to start the DC compressor. This way, the compressor works and starts softly. Other than this, the company has installed some sensors here, and I see 3 sensors on the PCB board. NTC is written on this one, but I guess it is a PTC sensor. Next, this is undoubtedly a PTC sensor, and this one is also a PTC sensor. Other than this, a small PTC sensor is installed in this control board, and let me tell you the reason for installing them in the PCB board. When due to any reason, the system overloads, the PTC sensors heat up. Then the resistance value of these PTC sensors goes too high, and thus the system turns off. So it is used as a safety device in this PCB. Before repairing this PCB, I will check the outdoor control board by connecting it with the indoor unit control board. Because I noticed the following thing: the company makes the PCB in such a way that until and unless the indoor and outdoor are connected with each other, no function will work on the outdoor, and neither it will do the switching. So let's first check it and then see the next step. I gave the unit an electricity supply, and the indoor unit has been turned on. I have set the temperature at 16 degrees, and it started working. I am showing you how is the outdoor unit PCB functioning now. I passed the electric supply to the outdoor PCB and installed the multimeter to check the communication voltages. The PCB is working on AC voltages, and the communication voltages on the multimeter are not fluctuating. Now let me check the DC voltages. The voltages are not changing on DC voltages as well. So this means that this inverter AC outdoor control board is dead. Let's start repairing this PCB and find the fault of why the PCB is not working. It is showing an E6 error on display, which is a communication error. The issue is not of the wire but of the control board. Now I have passed electricity to the outdoor PCB without the indoor PCB. Let me show you the input voltages on the terminals. 229 volts are flowing through its terminals. Now I will check the voltages on the different points of the control board. We should get some voltages on the 2 center pins of the bridge rectifier. 0.422 volts are flowing here, which is nothing. This means the electricity is not passing from here. Now I will check the electricity on these capacitors. On the PTC sensors. Other than this, on these fuses. Now I have placed the PCB on the backside. First of all, I am checking the voltages on the capacitor. This is the SMPS capacitor. The multimeter is showing no voltages here on the capacitor. Here the bridge rectifier I showed you before is installed. I have often seen that these kinds of PCBs have bridge rectifiers installed here because it supplies electricity to the SMPS. But here, diode 3 and 49 are installed. This might be used to pass electricity forward, and I need to check it because without studying it, I will not be able to work further on this PCB. I think a half-bridge rectifier wave has been used here. And the system is turning on through them. But no electric supply is passing. A fuse is installed here, joined with the NTC sensor I told you about in the earlier section of this video. Let's test these line filters to see whether the electricity passes here or not. 229 volts are passing here. This means that the other part of the PCB is not receiving electricity. Now I am removing these components. I removed this capacitor. I am removing its PTC sensor as well. Removed one of its PTC sensors. The second PTC sensor is installed here. Remove the second PTC sensor. To repair this PCB, we will understand this PCB. So see, this is the line filter installed here. Let me show you from the front side. The first line filter, second line filter, and some capacitors are installed to filter the electricity spikes. Then the electricity flows on this point, so this is the neutral point because the neutral wire is here, and the phase wire is here. This is the neutral side, and this is the phase side of this PCB. Then the electricity flows toward the PTC sensor, which I had removed. Then this wire trace goes toward the PTC sensor, and after this PTC sensor, the trace wire goes downwards here. So you can see these jumpers here. This is the position of the jumpers. Actually, no jumpers are installed in it. After this, a fuse has installed. And after it, a PTC sensor has installed. But these 2 points have no jumpers installed inside them. Now I will have to find where the electricity will pass from, and then I will fix that point. If I see this part of the PCB, the electricity from this point, the point where I showed you the neutral, which is joined with this wire. This is directly going toward the capacitor. If we see it from here, a fuse is installed. The electricity passes through the PTC sensor. After the PTC again, it is attached with this point inside. And let me show you where this point is joined on the back side of this PCB. That point is joined to this point. And this point has 2 diodes installed. But the electricity doesn't flow till here. Now let me tell you what the company did here. What is the mistake, or may I call it a blunder? As I showed you, these jumpers from the back side of the PCB, jumper numbers 2 and 3. These are not joined together. But jumper numbers 4 and 5 are joined together. Jumper number 2 and 3 should have joined, as was no need to join 4 and 5 jumpers. Because when I see the PCB from the backside, the PTC sensor wire traces are till here. The electricity should pass through 2 and 3 number jumpers, and no jumpers on the 4 and 5. Then the relay will join them together. This is the blunder that the company has made. Now I will fix it and check whether this PCB works or not. Now I have removed the jumpers. Let me show you from the front side of the PCB. I have removed jumper numbers 4 and 5. And installed it in jumper number 3. Now let's check the PCB works or not. I have passed electricity through it and see the PCB has started to work. The switching IC switched on. The red and green LEDs have turned on. Now I will check its electricity voltages. First, I am testing the voltages on the capacitors. Now I am getting 314 DC voltages on the capacitors. This means the PCB is in working condition now. I will attach it to the indoor PCB and check its communication. Now I passing electricity to PCB. The indoor unit has started. I will turn it on with the remote. And if I see the communication of the PCB, the DC voltages are fluctuating. Now I have converted the voltages to AC on the multimeter. The voltages are fluctuating on AC electricity as well. This means the communication system of the PCB is working fine now. It is showing F4, F5 and F3 errors, as its sensors are not attached to the PCB. That is why this air conditioner is showing these faults. And now this air conditioner is ready to be shipped to its owner. Click on the left or right thumbnail on the screen to watch out next videos. And subscribe, it's free. Thank you.